All right, 2-4A. We are solving equations with variables on both sides. Okay, now here's the thing. This one looks a lot like yesterday, but the equal sign is in a different place. So you do a different process, okay? I don't want you mixing this up with what you did yesterday, okay? It's not just combining both sides or combining like terms on one side anymore. So maybe write this little note to yourself, okay? When your variables are on opposite sides, girls, stop dancing and do this with me. When your variables are on opposite sides of the equal sign, you don't combine like terms. Okay? Don't combine like terms. You cancel them out on one side. Okay? This is huge because if you do this wrong, you will get a wrong answer every single time. Okay? We are not combining like terms if the variables fall on both sides of your equal sign. Let me show you what I mean. Let's say our equation, for example 1 here, is this. (5x plus 2) equals 2x plus 14. Okay? Let me show you how this is different from what we did yesterday. Yesterday, we did this. 5x plus 2 plus 2x equals 14, right? Our two variables both fell on the left side of our equal sign, right? Today, here's our equal sign. Now my variables are on opposite sides of the equal sign. You will get very different answers for these two problems, okay? So we're not doing this right now. We're doing it a new way now because of where our variables fall. So think about it, whatever you do to one side of an equation, you have to do to the other side. Serena, put your phone away. So if I want to get my x's together, which one would you think you should get rid of on the one side? Okay, so here's the thing. There isn't a right answer. You could do either, okay? I think there's a simpler answer. So when I do it, I always try to keep my x's positive. So think about it this way. If there's 5x on the left and there's 2x on the right, if I want to get rid of the 2x, I would subtract 2x, right? Well, whatever you do to one side, you have to do to the other. So I'm going to subtract 2x on that side. Those are not division bars, by the way. They kind of look like they are.
Mrs. You left it?
Yeah.
Yeah.
Okay. So here's the deal. 5x minus 2x, well, 2x minus 2x is nothing, right? 5x minus 2x is 3x. Now look at it if I had gone the other way. 5x plus 2, I'm just rewriting the same equation. Don't do this with me. Just watch. Okay? I could go take away the 5x from both sides. And this is gone now. And now this would be a negative 3x. It's not wrong. It's just an extra step at the end if you make your x negative. Okay? So I always try to move it so that my x stays positive. It doesn't have to be, and it won't always be, but it just gives you one less step in the problem. Okay? Melian.
The exponent, the variable.
There's no exponent.
The
variable?
The variable is 5x, right?
The variable is x.
Why you distracted because it's Multiplication. Oh.
No, it's saying, think of it as like 5 apples, and we're taking away 2 apples, right? 5 x's, and we're taking away 2 x's.
It's like it's multiply.
Right, but we have to get them together first, and then we can do the subtraction, division, all of that, right? So we're first going to get them on the same side of the equal sign, and then we're going to do what you're talking about. Okay, here we go. Look at your new problem. Okay, so we subtract, we get 3x over here. What's left on the left side of my problem?
14.
No, the left side.
3x plus 2.
3x plus 2. Really? Right, but you still threw something in my classroom. Right, but my point is, don't throw things, right? Yeah. Okay, so 3x plus 2, bring down your equal sign. What are you left with on the right side of your equal sign? 14. Okay, so now your new problem is this. Let me just clean it up because it's kind of messy here. Right? And that you know how to do. You've done this over and over and over again. What do you do first?
Subtract 2.
Take away 2. So you get 3x equals 12. And then what do you do from there? Now you divide by 3. So x equals 4. Okay, and you can always go back and plug a 4 in here and plug a 4 in there and check that they are actually equal so you know you have the right answer. Okay? Let's do another. Let's say you have 7k plus 2 equals 4k minus 10. Okay? Notice where your equal sign is. It's smack dab in the middle. You have variables on both sides. So can you just say 7k plus 4k right now?
Yeah. No.
No, right? Because there's that equal sign in the middle of them. So we have to get rid of it on one side so we can move it to the other. How do I get rid of one? And which one would you get rid of? Take away the 4k. Okay? If you took away the 7k, that's okay. You're just going to get a negative, which means in your last step, you would have to divide by a negative. Not a problem, just not as easy. Okay? So we're going to subtract 4k on both sides. And make sure you're only subtracting from things that have a k, right? You can only combine like terms. So this goes away, and I'm left with 7k minus 4k is 3k. What else do we have on the left side? Plus 2, okay? Bring down your equal sign. What do we have on the right side?
Negative.
Negative 10. Don't forget that negative. Very easy to forget that guy. Okay, what do you do from there?
It's the same answer.
The same thing. Subtract.
Take away 2 from both sides. So this is gone. You end up with 3k equals negative 12. And what do you do from there? Divide by 3, divide by 3. So you end up with k equals negative 4 because you had a negative 12, right? Okay? Again, you could plug it in here and here to double check. Okay? How do you do this problem? 2k plus 5 minus 3k equals 12. Notice where your bar is, right? Your equal sign is there.
Oh, so we just do like if it was.
Like no.
Now you have to do like yesterday, right? Combine like terms. If they're on the same side, you may combine them. If they're on opposite sides, you need to get rid of one, right? So 2k minus 3k is a negative 1k plus 5 equals 12. We're going to take away the 5. So negative 1k equals 7. No, negative 7, because you have to divide by negative 1, right, to get the negative out of there. So k is negative 7. Okay? What would you do with this one? 15p equals 12.5p plus 80. Okay, think about where your equal sign is. Are we gonna combine the 15p and the 12p, or are we gonna cancel one of them out? Cancel one out. When they're on opposite sides, you gotta get rid of one. Which one would you subtract?
12.
The 12.5. So if I take away 12.5p, then I gotta do it over here too. Okay, this is 0. This is 2.5p equals 80. Okay, you're gonna divide by 2.5, and p comes out to 32. So is that clear when you move one to the other side versus when you combine like terms?
Yeah.
Yes? Okay, pay attention to where your variables fall. That is the whole lesson.